All right, we're going to do a brief review of logarithms. Okay, and so here's my brief review. This is not a log equation. You know how to solve that. You divide by 2, both sides. X squared equals 5. You know how to solve that. You take the square root of both sides. And remember, when you're taking even roots, square root, fourth root, the answer would be, in this case, x equals plus or minus the square root of 5. Taking the square root, or taking both sides to 1/2 power. But if you had something like this, doesn't solve by doing our traditional divide by 2 or whatever, or none of the methods work. But a gentleman that was dealing with power equations like this decided that I'm going to rewrite this. He's going to rewrite it using the word log. Now, my translation of the word log, and you're going to hear me use it a lot in here, is to what power do I take blah 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 to get blah blah blah. The first blah 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 is the base. Now if I have an exponent, this is called the base exponent, So the base is 2. For the log, we write the base as a subscripted 2, lower down 2. So this says, to what power do I take 2 to get 5? And from this equation up here, it says, if I take 2 to the x, I get 5. So to what power do I take 2 to get 5? I take it to the x power. This is nothing more than rewriting this. This says, to what power do I take 2 to get 5? This says, to what power do I take 2 to get 5? The difference is x is in a power position, and here x is down on the regular line of the equality. It doesn't look like a power, but it is a power. It's always been a power. So a log is a power. To what power? Okay, so we've got to hang on to that idea as we go through this. So now our log rules are basically power rules. If you were multiplying two things like 2 to the 5th times 2 to the 3rd, same base, what do? Well, we add the powers. We get 2 to the 8th. Well, to what power do I take? And let's just use, we can have any base we want, but I'm going to assume, and when we write log without a base on it, it's assumed 10. So I'm going to say 10. To what power do I take 10? Let's say 5 times 7. Two things multiplied. So I can say, well, okay, to what power do I take 10 to get 5? And I can say, to what power do I take 10 to get 7? And if I can figure those two answers out, and I need to multiply those two things, this is the power of 10, this is the power of 10, and am I multiplying those two things with these powers, I add the powers. So in general, the rule is log any base of two things multiplied is the sum of the logs. In whatever base they were in. Same logic if I have, this is called the product rule because we're multiplying. if I'm dividing two logs, or have a log of a division problem, then when I do powers like 2 to the 5th divided by 2 to the 3rd, I subtract the power. So it becomes log base c of a minus log base c of b. So here's the product rule, here's the quotient rule, and what's the power rule? What do we do when we take 2 to the 5, let's say, to the 3rd, which of course means 2 to the 5th times 2 to the 5th times 2 to the 5th, multiply it 3 times, which is 2 to the 15th, and you can see that's just multiply the power, so that's what you do. So the power rule is if I have log with some base of a to the some power b, this says to what power do I take 10 to get a, and then I take it to a power, so I multiply the powers. This power times this power, so I get b times log base c of a. Now we sometimes say we just bring the power down, but it's basically following the rule here. We multiply a power times the power. Okay. Now the first one they asked for was what's the equation to a log expression. So if I write that in general form, if I have b to the a equals c, if I want to change it to a log thing, I say log, the base of the power here is b, so I put b as a subscript. To what power do I take b to get c? And the answer is the power is a. This is a power, that's a power, that's a power. Okay? Now, if I still wanted to solve for x in this, I still need to go one step further. I need to figure out how to figure this out. And so we have a change of base. Now, on your calculator, you come equipped with 2 buttons, log base 10, and up here there's a 10 to the x. That's helping you remember that that's the one with a base 10. And this is ln, natural log, which is base e. They made tables for those two in your calculator. So, this is base 2, not 10 or e. So I'm going to tell you what the change of base rule. If I have log in some base I don't like b and of a, and I want to change to a more likable base like 10 or e, it becomes the log in the new base c, maybe 10, maybe e, whatever you want to use for c, of a over log base c of the base. Now I'm going to really emphasize that it doesn't matter which base you want to do here by clearing this and saying, all right, so to do this problem, log base 2 of 5, I would take log in any base I like. So I'm going to do log, that's in base 10 because that's the log button. I'm done here. The log button. Log of, what was it, 5 divided by log of 2. Log of 5 divided by log 2, close parenthesis, and I get this number. That should be the power that I take 2 to get 5. Let's check that. So I'm going to take 2 to that answer, second the negative sign, and it says 5. I found the power that I can take 2 to get 5. The power that I take 2 to get 5. Now I did it in base 10. Now I'm going to do it in base ln. natural log, base e. So I'm going to do log, natural log of 5 divided by natural log of 2. Notice I get the exactly same answer. So it doesn't matter which base, 10 or e, when I do this change of base rule. And it could be any other base if I wanted. Now the final thing, I gave you a problem that sort of looked like something like 3 to the x plus 1 times 7 equals 2 to the 3x. And we want to solve for x in something like this. This is the most difficult one. And we're going to use our log rules here to solve this. All right. Now, one way to do this is, okay, if this is a number, and this is equal to that number, so it's the same number, then I should be able to say, to what power do I take, and it doesn't matter, 10 or e, I'm going to do 10 here. To what power do I take 10 to get this number? Yeah, so whatever power I take 10 to get this number should be the same power I take 10 to get this, because these are two of the same numbers, so the power I take 10 to get those should be the same. So this should be the same. And now I'm going to use my log rules to separate this out and make a little bit more sense out of it. Now there's a power, but it's only on the 3, and these are times, so I'm going to use my product rule first and separate this into the log base 10 of 3 to the x plus 1 as the power, plus, because it's a product, so you add the logs, the log base 10 of 7. So I've taken this product apart. This one, I have a power on it, and so I'm going to use the power rule, and that power comes down times it, so it becomes 3x times log base 10 of 2. And now, since this has a power on it, I can take it down times, so I can rewrite this as x plus 1 times the log base 10 of just 3. Now I'm going to look that up. Log of 3, and that happens to be 0.4771. 0.4771 plus log base 10 of 7. So I'm going to go log 7, and I get 0.8451. 0.8451 equals 3x times the log of 2. And that's 3010. 0.3010. Now, this should look like an Algebra 1 equation to you. And should be, oh, I know how to do this. You take this times the x, so you get 0.4771x plus 0.4771 plus 0.8451 equals 3 times that would be 0.9030x. Algebra 1 problem with messy coefficients. Yeah, but we can still do it. Let's subtract these x's from those x's. So 0.9030 subtract 0.4771 and get it out of that light, and I get 0.4259. 0.4259x. Put these together, so that's 0.4771 plus 0.8451, and I get 1.9 322, and now I'm going to divide both sides by that. Divide by 0.4259, and I get 3.104 is what x is. Now I'm going to check my answer here. Okay, so when I went from here to here, I started doing approximates. These are all just approximate because they're decimal approximations. So my answer should be approximately correct. Let's find out. So I'm using that for my x. So I'm going to figure out back here what is 3 to the power of, one more than that would be 4.104 times 7. That's this side. 635.6 whatever. Okay. Now let's see if this comes out to be close to the same. 2 to the 3 times 3.104. And I would say that looks awfully close to the same. 635.6. Okay? That's the brief idea of what logs are.